recording. Okay, we stopped here last time. We are still talking about the manufacturing economics, and this is the cost equation. I remind you what we was discussing last time. This is the cost equation, and we said that cost equation CBC, which is dollar per piece, one piece. So we focusing as we described last time. We're focusing on one piece, so dollar per piece. So CBC يعني means the cost of one piece, dollar per piece, equal to CM plus CL plus CEQ multiplied by TB, CL CEQ multiplied by TB plus CT. And CM, which is a material cost, raw material cost for piece, for one piece, dollar per piece. So you can see that CM here. CM is a material cost. CM is a material cost. Material cost means raw materials, the raw materials that we use to manufacturing the part. So dollar per piece for one piece. Also CT here, you can see that this is the tool cost. And also we described that last time, if you remember. This is the tool cost, dollar per piece. I told you that last time we discussing this, when we were discussing this one, I told you that the tool probably can be used to machine or to manufacturing many parts. For one tool, for example, it could be manufacturing 10 parts. So a tool costing, for example, $10, and this tool be used to manufacturing 10 pieces. Then how many dollar per one piece? It is $10 divided by 10 pieces. It means that $1 per piece. So this is a CT, this is a tool cost, this is the material cost. CL and CQ. CL is a labor cost. Labor cost, يا شباب, it means that is a salary of the man, the technician who working with the machine. And as I told you last time, technician salary usually per minute, per time. هو بياخد salary بالوقت مش بالقطعة، لأن maybe he manufacturing or machining one piece take one day, and maybe another product one piece taking maybe 10 minutes. So we cannot just say dollar per piece. We can say dollar per time. So his salary usually is dollar per time. He's getting, for example, $10 per day. Means then how many dollar per minute? And you can see this is the CL, dollar per minute. CEQ also dollar per minute, CEQ, which is equipment cost, dollar per minute as well. And this term, which is a CEQ, if you realize is CEQ plus CL plus CEQ, this term is, you can see here, it is dollar per minute. Both are dollar per minute. So you have to multiply, because finally we need to get dollar per piece, then you have to multiply by TB minute per piece, TB, which is how many minutes. So dollar per minute, for example, if they costing both together costing $5 per minute, CL and CQ costing, for example, $5 for 1 minute, then this part one piece, how many minutes? This is a TB. TB is how many minutes we need to machining one piece. For example, this is 5 minutes. So this is $5 per minute, $5 per minute, and we need 5 minutes for one piece. Then you get $25 per piece, because this one costing $5 every minute. Every minute $5. And we need 5 minutes, then $25 per piece to complete machining one piece. So finally, we have dollar per piece. That's what we was discussing last time, and this is the cost equation. This is the cost equation, right? Then this is a CL. CL is a salary. Salary mean is RH divided by 60. RH is hourly wages. RH here is hourly wages. يعني الساعة. Salary بتاعه في الساعة divided by 60. You get dollar per minute. This is a CL in very simple way, which is a salary, the technician money, which is $1 per minute, right? This is dollar per hour. Equipment cost CEQ equal to IC divided by 60 NH. Also last time we discussed this one. I told you, let's have this one. If you remember, I told you that last time. IC IC divided by 60 NH. IC يا شباب, IC is the machine cost. IC is the machine cost. Machine cost, for example, 100,000 real, for example, or dollar or whatever, right? So 100,000, then IC is the machine cost, 100,000 dollar, 100,000 real, whatever, divided by, because we need what? Dollar per minute or real per minute or dollar per minute. So minute, we need minute. This machine anticipated to work for 7 years. N is a number of year. So we can say that this machine anticipated to work for 7 years. 7 years. 7 years multiplied by number of hour per year. For example, this is 50 week per year. 50 week per year multiplied by 5 days per week multiplied by, right, 8 hour per day. If you have like this, then this is 7 years. This is 7 years. This machine working for 7 years. It is anticipated to work for 7 years. Manufacturing says that. If you multiply by 50 and 8, this is the number of hours per 1 year. If you multiply by 7, you get number of hour in 7 years. In this way, it is dollar per year. It is dollar per year. You need to multiply this one. You need to multiply by what? You need to multiply 60. Then when you multiply 60, then you get dollar per minute. Dollar per minute. This is a machine cost. So this is a cost. This is the price of the machine. You divide by the number of minutes per year. This is the number of minutes per year for 7 years. How many minutes in 7 years? Right. In very simple way, how many minutes in 7 years? Then you get dollar per minute. So this is a dollar per minute here. So it's dollar per minute and dollar per minute for labor and equipment. Right. This one leading us to the cost equation. So cost equation again, CBC equal to CM material cost, CT is a tool cost, CL plus CQ multiplied by TB. This is manufacturing cost or the cost. It is actually, if you look to this equation, you can find that this equation is manufacturing equation, manufacturing cost equation. However, there are many other costs. There are many other costs, not only for manufacturing costs, but there are many other costs. Like what? There are many other costs must be counted as well. Like what, ya shabab? Like what other costs must be considered? Not only manufacturing. We have many other support section in a company. This is only manufacturing cost. You see material, technician working in the machine, equipment that you use, and this is a tool. So this is the manufacturing cost. However, as I told you, there are many other additional costs must be considered. Like what? Like supporting department must be considered. Like what? Like supporting, like design, like planning, like quality control, like research and development, like administrative work, sales, marketing, medical, insurance, transportation, electricity, tax, water, whatever, right? And finally added the profit. So all these costs are not considered. This is only if you look to this equation. This equation actually describes only this section. So this equation only describes this section, which is the manufacturing cost section, right? Which is only around 40% of the total cost, as you can see. So this equation actually describes 40% of the total cost, which including this kind of item, material, labor, equipment, and tool. What about this one? This one is cost, must be considered. You cannot identify the price of the product unless you put this cost as well. And you see it's counted for 60%. If this one counted for 40%, this one counted for 60%. And must be considered. How to consider? The question is how we consider this other cost. How we consider, the question is how we consider this other cost in the cost equation. Then now we can understand that, or it is realized that we must modify the cost equation to count it or to include it the other additional cost that not included yet. Any question? Any question? Is it clear?
Yes, it's clear. Yes, it's clear.
Right. So now,
Yes.
now we would like to modify. Now we would like to modify, or we have to modify the cost equation to include this other additional cost. Right? Okay. What is the additional cost? The additional cost, we call it overhead cost. All this additional cost, all this whatever we discussed now, we call it is the overhead cost. And overhead cost could be factory overhead and cooperative overhead, including all what we just described. So factory overhead excludes material and labor, but it includes plant service, maintenance, insurance, heat, light, and so on. This is a factory. Cooperative include cooperative overhead. They call it like this, overhead cost. So cooperative overhead includes sales, will marketing, will accounting, will legal, well engineering, well research and development, well, and so on. So this is a kind of cooperative. This is a two different type in overhead cost. So all additional we call it overhead, which is factory overhead and cooperative overhead. Right. And now we would like to modify the cost equation to include this kind of overhead cost. They said that this overhead cost generally, both of factory and cooperative together, very difficult to be counted. Listen to me carefully, ya shabab. This overhead cost is very difficult to be counted. Very, very difficult to be counted. You cannot just count everything, like telephone, you see the telephone, it's marketing, you talk about transportation, to light, to water, you talk about the research and design and the maintenance, insurance, quality control. Very difficult to count every single item very accurately and consider in the equation. Very difficult. So how people can deal with this kind of overhead cost? How we can include this overhead cost in the cost equation? Actually, they said that we're going to add the overhead cost. People said like this, we're going to add the overhead cost, this one, right? We're going to add the overhead cost as a percentage in labor, as a percentage in labor section and equipment section in the cost equation. They said that we're going to have the overhead cost as a percentage in labor section and equipment section. Why? Because that usually this overhead cost is the two parts. One part related to the labor, another part related to the equipment. So labor mean what? Labor meaning those people who are working in other different departments, like people working in the maintenance, people working in the transportation, people working in different other sections, research and design, quality control, and so on. So people work in different sections. And the equipment, other equipment like cars that being used in the transportation, faxes, telephone, computers, and so on. They say that overhead cost mainly overhead cost is considered as labor and equipment. Then they're going to add this overhead cost in a labor section and equipment section. They're going to add this overhead cost as a percentage in the labor and equipment, one by one. In labor, what is the labor? Labor is the salary of the technician. So this is the only salary of the technician. RH divided by 60 is the salary of the technician working on the machine. What about other people who are not working with the machine? We're going to add it as a percentage of this guy. So we call here, so RH multiplied by 60, multiplied by, for example, 1.5. 1.5 meaning you added 50%. So it is multiplied by 1 plus RLH. RLH here is the overhead rate. This is the hourly wages. This is the RH is the hourly wage for this person who working with a machine. RLH here is the labor overhead rate. Labor overhead rate. So this is the, let me just highlight, this is the labor overhead rate. So this is the one. So this is the first part. So this is the first part of the labor overhead cost in the labor. So overhead cost in the labor, we're going to add it as RLOH. So this is the part before, if you remember, this is the CL, RH divided by 60. We added the overhead rate as a percentage of the salary. So it is 1.3. For example, if this 30%, for example, if you put RLOH, which is overhead rate, maybe 0.5 meaning 50%, then 0.5, then become 1.5. Then this salary multiplied by 1.5 as a percentage. So this 1% from this, right? So this is a way to add it. Someone said this percentage could be added within certain range, it will not be accurate and so on. I told you that at initially you have to, at the beginning of the company, you have to add it from around 40 to 60%. You keep it within 40 to 60%. And later on, you can just tune this value, modify the value based on the numbers that you have. Because Muhammad, just give me a minute to finish this one and ask me. Because this one very dangerous. If you put it very high, then you get high value here, and then the cost of the, or the price of the product will be very expensive. When you put in the market, you lose the market as well. We don't want to lose the market, and this one must be reasonable. So usually RLOH usually is 40 to 60%. They keep 40 to 60%. Someone said, why 40 to 60%? Because if you get back again to here, you see that manufacturing cost is 40%. The additional cost is around, just remove the profit, remove this one, is this additional cost usually around 50%, 50 to 60%, 50 or 40 to 50 or to 60%. So that's why they consider this kind of ratio. That's why they consider this kind of ratio. So RLOH could be added as a percentage in labor. Equipment, same also. We're going to add the overhead cost as percentage in equipment. So CEQ, this is the equation of CEQ equal to IC divided by 60 NH. This is the equation of CEQ. This is the ROH. ROH mean, ROH is the labor overhead, sorry, not labor, equipment overhead cost. Applicable overhead rate of equipment. So you added here, so become, you multiply. So it is this one. If you remember, this is the equation of CEQ. This is previous equation of CEQ. And now multiply by percentage. So if you added 30, added 30%, 40%, 50% additional ROH, then become multiplied 1.5, 1.4, 1.35, and so on. Then you get new CEQ. And in this way, you can modify the cost equation. Yes, Muhammad, if you would like to ask, I'm listening.
Yes, Doctor. Does this percentage of the RLOH take in consideration when the labor are sick or something like this? That's the reason why we add like additional value.
Yeah, it should be considered as well. Right. It is considered, and because this kind of overhead, including the medical and including the insurance, including all
Okay,
this
so
kind of
everything
items.
is reasonable.
Yeah, everything. They approximately, let me say approximately. There are no, because it's different from case company to company, understand me? So approximately they find that it is 40 to 60%, including all what you're discussing now. So it should be, yeah, it should be included. Yeah, it should be included, right. Okay, let us take an example. Let's take an example and see how to deal with this one. A production machine is purchased for an initial cost plus installation 500,000. This is the machine cost. This is the IC. Let me write here. This is the IC. IC in equation IC. So IC equal to what? IC equal machine cost equal to 500,000. Initial cost plus installation. Because installation is part of the machine. So initial cost plus installation 500,000. This is the machine cost. This machine anticipated to work for 7 years. Who said that? Company. The machine manufacturing guy says, the person who's selling the machine said this machine is anticipated to work for 7 years. So machine anticipated to work for 7 years. Machine is planned for 2 shifts per day. In every day, 2 shifts, 1 in the morning, 1 in the evening, 8 hours per shift, meaning 8 hours in the morning, 8 hours in the evening. That means that in one day, it works 16-hour day, 16 hours per day, 5 days per week. So we have 5 days per week and 50 weeks per year. So 50 weeks per year, 5 days per week, 16 hours, 2 shifts in 8 hours, meaning 16 hours per day. And the applicable overhead rate of this type of equipment, 35%. So overhead rate, 35%. What is the equipment cost rate? Equipment cost rate, CEQ equal to IC. This is the IC, which is the machine cost here. IC, this is the machine cost, so it's 500,000 divided by what? Divided by 7 years. 7 years multiplied by the hour per year. Hour per year we obtain, this is the 50 week, 5 days per week, 8 days per shift, 2 shift means 16 hours per day, 5 days per week multiplied by 50 weeks, then you get 4,000 hours per year. Then 7 years multiplied by 4,000 hours per year multiplied by 60 to get minute. And then here, this one is equipment cost, but we need to add it overhead rate. Then when you added the overhead rate, it is 1 plus 0.35. 0.35 means 35%. So 35% added as 0.35, then 1.35. Then this one, which is equipment rate or equipment cost here, multiplied by the overhead. This is a we added the overhead rate, so multiply by the 1 plus overhead rate, the equipment overhead rate, then you get this $1.402 per minute or dollar per hour. It depends on what you need, right? Is it clear? Any question? Clear. Perfect. Okay, so move forward. Another example. This is another example, a production machine, same as we describe here. We continue with this one. So in this step, we already calculated CEQ. In this step, we already calculated CEQ. We continue now. We continue with this one. Yes.
معلش السلايد اللي قبل.
Yep.
60 اللي في المقام ليش ضربت فيها؟
دي المينت. This day hour per 7 years you multiply by 60 to get minute. 60 دقيقة.
تمام.
دي عشان الساعة، دي 4000 ساعة في السنة. multiply ب7 سنين يبقى أنت عندك دي عدد السنين في عدد الساعات في ال7 سنين. بتضرب في 60 عشان تجيب minute. تمام؟
Yes, okay.
In this step, as I told you, we calculate CEQ. So this is a CAQ. تمام? This is the example. Next example, we continue with this one. We're going to continue. So production machine in example 1.1, which is the previous slide, is used to produce batch part that each has starting material cost. This is the material cost. material cost قد ايه يا شباب؟ اهي. material cost اللي هي ايه؟ CM material cost, which is a dollar per piece. The material cost, starting material cost اللي هي raw material. This is starting material cost, raw material, which is $2.35 per piece. Batch quantity 100, mean Q is 100. This is the batch. The actual processing time in the operation 3.72 actual processing time تمام. actual processing time in operation 3.2 minute. total load and unload workpiece is 1.6. دي الاوبريشن تايم التي او اهي. this is TO operation time. this is operation time TO. loading and unloading workpiece, this is the TH 1.6. tool cost is 4.4. this is the tool cost. tool cost is $4.4 and each tool can be used for 20 piece. يعني خلي بالك من دي يا شباب، خلي بالكم معايا. التول تكلفة التول 4.4 دولار دي للتول، والتول الواحدة بتستخدم تقطع 20 قطعة. يبقى لما نيجي نقول دولار بير بيس، يعني الكوست بتاعت التول دولار بير بيس ايكوال كام؟ 4.4 على 20 يديك الدولار بير بيس. خلي بالك من الحته دي before it change. تمام. which take 2 minutes. اللي تشينج بتاع التول، تغيير التول بياخد دقيقتين. طيب 2 minutes to change the tool after how many piece؟ after 20 piece. يعني التول being used for 20 piece and then we change the tool. change the tool. this is the tool handling time TT. TT is 2 minutes for 20 piece, but we need minute per one piece, so 20 divided divided by 20, you get how many minutes for every piece. Right. Before production can begin, the machine must set up. Takes 2.5 hours. This is the set up time. Set up time. The set up time is 2.5 hour. This is the set up time. Setup time, you know that it is in hour. You can change to make it minute. Definitely hourly wages rate for operator is, this is the salary, hourly salary for operator $16.5 per hour, and applicable labor overhead rate, this is the labor overhead rate is 40%. determine the cycle time. This is the first. Second, average production rate. Third, cost per piece, one by one. First one, cycle time. When he asks you for cycle time, then put the equation. I suggest you to put the equation. So this is the equation, cycle time equation. Put the equation. So cycle time equation equal to TO plus TH plus TT. تمام يا شباب؟ TO اللي هي الاوبريشن تايم. اوبريشن تايم هو اداني هنا 3.72. This is the operation time. TH is the handling time, it is 1.6 workpiece handling time. TT is the tool time, tool change time. Tool change time is 2 minutes, 2 minutes for 20 piece. 2 minutes after 20 piece, then you divide 2 by 20. 2 by 20, this is the TT, 2 by 20, as you can see here. Then TT is 2 by 20, it is, as you can see, it is 0.1 minute, then you put 0.1, this is the TC. This is the first question. What is the cycle time? What is the cycle time? What is the cycle for one piece? Right? This is the first question. Second question, what is the average production rate? What is the average production rate? I said what? Production rate. Production rate equal to what? Do you remember? Put the equation. Put the equation.
TB over.
So RB, the 60 divided by TB. Average production rate, RB equal to 60 divided by TB. Then this is the average production rate. Average production rate, this is the one needed, equal to 60 divided by TB. Then I need to obtain TB. I need to obtain TB. TB equal to what? TSU, which is a setup time, divided by Q plus TC, cycle time. TC already we obtained in the last step. This is a TC already we have here. We obtained already. So TC we know. TSU is given 2.5 hour. You multiply by 60 to get minute. 2.5 hour, which is a setup time. Multiply by 60, get minute. You divide by 100, which is batch quantity. Q plus TC, then you get TB. This is a TB minute per piece. Minute per piece. We need hourly production rate. We need hourly. Then 60 divided by TB to get hour. This is minute per piece. If you said that RB equal to 60 divided by TB, you get hourly production rate, which is 8.67 bees per hour. Bees, how many bees per hour? Right. This is the average production rate. And finally, the last question, cost per piece. Cost per every one piece. Cost per piece actually can be obtained as both the equation. This is the equation actually. Cost per piece equal to Cm plus Cl plus Cq multiplied by Tb plus Ct. This is the equation, right? This is what we need. Cm given, he gave me this one, Cm. Ct, be careful because Ct, the cost of the tool, is here. If you remember, cost of the tool is 4.4. This is the tool cost $4.4, right? And the tool being used for 20 pieces, then the cost of the tool equal to what? Equal to 4.4 divided by 20. 4.4 divided by 20, right? So Ct equal to 4, Ct here, as you can see. Ct here equal to, this is the one, equal to 4.4 divided by 20. This is the Ct. So Ct here obtained. Cl equal to the salary of the person per hour. This is the hourly salary divided by 60, get in minute. You multiply here by 1 plus C. This is the LOH overhead rate 40%. Then salary you divide by 60 to get minute. Multiply by 1.4. 4 is the 40% overhead rate. Then you get the CL. This is the CL value. This is the CT value. CM is given. Still CEQ already we have in the equation here. CEQ already we have in the example 1.1 because this is a continuity from example 1.1. So CEQ already we had. TB we have here already. Then you use TB, then you get the CBC. CBC is the cost per piece. It's costing $8 per one piece. This is the cost. This is a manufacturing cost plus overhead rate. This is not only manufacturing, but manufacturing cost plus overhead rate. Overhead rate meaning the other cost for additional, items that not included in a manufacturing cost. Yes, Ahmed.
Yeah, sorry, doctor, but I didn't notice where we use the time for changing tools.
Cannot understand your question. What is your question exactly? Again.
In all these questions, where we use the time for changing the tool. Like there is tools that take time for
right. I understand. This is a TB, right?
Yes.
TB is here. TB in the equation, right? Can you see that?
Yes.
TB, right? TB equal to TC, TSCU divided by Q plus TC, right?
Right.
And the TC here, right? This is the cycle time. Cycle time including tool change time.
Oh, yeah, I got it now. Thank you.
Get it? So this is the tool change time in a TC, and we use to calculate the TB, and TB is being used here in the equation, right?
Yeah. Okay, thank you. I got
Clear?
it. Yeah.
Right. Any question, guys? Yeah. Any other question? No question? Meaning clear, huh? Right. If you have any question anytime, you can stop me. Right, definitely. Next is, this is very important. I hope you give me your full attention. We have what we call is availability and scrap rate. Availability and scrap rate. We have to consider also in the cost equation. What availability and what scrap rate? Let me explain to you. Just please give me your full attention. Availability, it means that machine available or availability of the machine during the time. Let's give you an example. In 40 hour, machine available 35 hour. In 40 hour, in total of 40 hour, machine was available 35. And 5 hour machine was not available. What is that mean? What is the meaning of that machine not available? Breakdown. So in 40-hour machine breakdown for 5 hours. المكنة عطلت 5 ساعات. يعني كل 40 ساعة المكنة بتعطل 5 ساعات، أو المكنة بيتعمل لها مينتنس لمدة 5 ساعات، فالمكنة غير متاحة في الوقت ده. يبقى الافيلابيلتي عندي كام في المية؟ يبقى الافيلابيلتي we donate as A meaning availability. The word A or character A mean availability. Availability equal to 35 divided by 40 mean availability is 70 or 87.5%. Did you get it? Right. This is the availability, right? This is the first item or first part. Second part, we have what we call is a scrap rate. Scrap rate mean، خلينا احكي لكم بالعربي يا شباب. scrap rate يعني الاجزاء القطع اللي صنعناها وطلعت بايظه او طلعت ما ينفعش نستخدمها لانها مش مطابقه للمواصفات. ليه مش مطابقه للمواصفات؟ فيها ايرور، يعني الاجزاء اللي صنعناها فيها ايرور. ف during 40 hour, during this 40 hour we consider all 40. During 40 hour we find that machine produce 336 non-defected, okay, non-defected mean okay parts, and also 22 defective parts. 22 defective parts. يعني عندنا 22 part produce defected. But in total is how many? How many parts produced? Total is 358. So 336 is okay, 22 not okay, total 358. What is the percent of scrap? This is the defective part scrap. Why scrap? Because I cannot just put this one in the market. This one defected. So I will not be able to put in the market, then it will be scrap. I will throw it away. Maybe I can recycle or something. This is not our focus now. So it is not being used. It is defected part. So what is the percentage of defected or scrap? What is the scrap rate? Scrap rate is 22 defected part divided by total. Divided by what? Divided by total, not by this one. By total, then he give you 6.15% scrap rate. So scrap rate 6.15%. Any question about availability or scrap rate? Okay, this is the availability and scrap rate. Right, just move forward. Let's take an example. Let's take an example about availability and scrap rate. In continuous production system, now listen to me carefully. Listen to me carefully. In continuous what? Continuous production. What is a continuous production system? This is a mass production system. Why is this one important? Because in a mass production system, TSU equal to what? There are a setup time, but we can ignore it. In a mass production system, we can ignore setup time. If you remember, then TB equal to TC. That's what we discussed last time. So setup time here can be ignored in a continuous production system. So here in continuous production system or mass production, same meaning. During a particular 40 hour, I will pick up 40 hour time to study. So it is continuous production system, but I will do analysis in 40 hours for an automated production operation. 336 acceptable non-defective parts being produced and 22 defective parts were produced. The operation cycle time, this is the cycle time, not operation time, but cycle time. Cycle time equal to TO plus TH plus TT. This is the operation cycle time. It means that to 6.23 minutes for every one piece. To manufacturing one piece, it consumes 6.23 minutes to make one piece, or take 6.23 minutes to machine or to manufacturing one piece. This is the cycle time. Machine experience several breakdown. Machine experience several breakdown during 40 hour, because we analyzing 40 hour among this production in 40 hour machine experience several breakdown. وقفت يعني اتعطلت اكتر من مره وتعمل لها صيانه. During operation, determine scrap rate and availability. We need to know what is the scrap rate and availability. Scrap rate يا شباب انتوا شايفين عندك ايه 22 defective and 336 non defective. Total is 358 358. So total 358. The scrap rate بيساوي كام بقى يا شباب؟ scrap rate equal to كام؟ ادي ايه؟ ادي السكراب ريت. سهله جدا، ده مباشر وسهل جدا. عندنا كام واحد defected؟ 22 defected divided by كام يا شباب؟ by 358, which is the total. So 22 is the defected here, 22 divided by total, which is 358. This is the scrap rate. This is very easy. Second is the availability. الماشين احنا دلوقتي بندرس 40 ساعة 40 hour. This is the time we analyze 40 hour. بس الماشين several breakdown قد ايه ما قاليش هي عملت. لو انا اعرف هي الماشين دي عملت بريك داون كام اور، مثلا لو قال لك ان البريك داون ده التوتال بريك داون حصل 3 ساعات، يبقى نقول مثلا يبقى الباقي عندنا كام ساعه؟ 3 من 40 يبقى كام؟ 37، يبقى الافيلابيلتي 37 على 40 يبقى دي الافيلابيلتي. بس هو ما قاليش قد ايه الوقت اللي حصل فيه بريك داون. طب هو قال لي ايه what is given operation cycle time. هو اداني السايكل تايم. السايكل تايم قد ايه يا شباب؟ 6.23 minute for one piece. يعني ده الوقت اللي استغرق يعني الوقت الماشينينج او الوقت التايم need to machine one part is this is the time 6 minutes to machine one part. طب احنا عندنا كام بارت؟ احنا عندنا 358. If you multiply this time by 358 give you what? Give you machining time. If you multiply the cycle time by 358 it give you the total machining. Someone said you have to multiply this 6.23 with a 336. No, I have to multiply this time operation time or cycle time. I have to multiply this cycle time by total. Why by total? Because even this 22 defective part already been machined. We spend time to machining this one. You cannot exclude. So the time spent for machining 22 and 336. So this time used to machine both, then you have to multiply by this one to give you machining time. If you know the machining time and this is 40 hour, you can realize how many hours is several breakdown. Let me just show you. This is the availability. This is the unavailability. 40 hour is the total. 40 hour is the total time, right? Cycle time is 6.23. This is the cycle time for one piece. Setup time here is 0. Why 0? Because this is continuous production system. They will consider is 0. TB equal to TC. Then TB equal to TC. Then the batch time for all product equal to Q multiplied by TC. Q multiplied by TC. It's supposed to be TSU plus Q multiplied by TC. TSU is 0. Then Q multiplied by TC. Q is 358. Q here equal to, I emphasize about this point, this is very important. Then Q here, خلوا بالكم يا شباب, Q here is, as you can see here, Q here is both. Q here is 358 multiplied by the time, the cycle time, or TB because TSU is equal to 0, then same, then multiply by TC here. Then you get this one is around 37.17 hour. So we can realize that a batch time is 37.17 hour. This is the batch time. This is the machine available. So when machine available, it is available for 37.17 hour. And during this time, machine used to manufacturing or machine 358 piece. From out total time is 40 means that it's breakdown for 2.38 hour. This is a breakdown time. This is a breakdown time. This is a machining time. So machining time availability equal to what? Availability equal to machining time divided by 40. So 37.17 divided by 40, you get 92.9% is availability. 92.9% is availability. So this is availability. Any question? Right.
Doctor, I have a question.
Now, yes, Ahmed.
Yeah. At the time we spent in the machining and then a defective part, what it called or what it counts?
It must be counted because machine already working.
Yeah, but we don't count it as a separate thing or something.
No, but availability, we talk about availability. This is scrap rate. Okay, I understand. But we talk about availability. Machine was available or not?
Yes.
So it is considered as part of availability. Yeah,
Okay.
available. Machine was available. What is the availability, Ahmed? What is the availability?
Tofu.
Machine available, right?
Yes.
Availability mean what? Machine available, right? It was available or not?
Yeah, it was available.
So it
But
should be considered. It means that it was available here and it was available here. For both, I mean, machine was available during this one and machine available also for this one, right? You agree with me?
Right. Now I understand.
So this is the availability. So this is the availability. When we talk about availability, it was available or not? This is a question.
Yeah, it was available.
Then it must be considered as available, right?
Okay.
But when you come to the scrap rate, this 22 will not be considered. Why? Because it is defected. Now, actually, machine produce, we don't know still defected or not. Machine produce actually is this one. Machine produce 358 piece. We don't know what is defected and what not defected. So machine produce this one. Later, when we check, we find 22 not okay. Then we will not consider because it is not or defected. Clear?
Yeah, clear.
Did you get it? Right. Any question, guys? Perfect. So, okay. Availability and scrap rate. So now we need to consider this availability and scrap rate in the cost equation. We need to consider availability and scrap rate in the cost equation. So this is the cost equation. CBC equal to CM plus CL plus CEQ multiplied by TB plus CT. Definitely CL here is the modified CL. CL plus including overhead rate. This CEQ including also overhead rate. Right. So CM plus CL, CQ multiplied TB multiplied by CT. Then we need to consider availability and scrap rate. Let's see together how to add availability and scrap rate to the equation. One by one. CM. So what is the CM? Material cost, raw material cost. Material cost will be affected with the scrap rate. Why? Because when you have scrap, it means that, if, for example, if you would like to manufacturing a batch of 100 pieces, right? And you already manufacturing 100 pieces. When you check, you find that 5 out of 100 are scrap. What are you going to do? Machining more parts. Then actually you have to make another 5. Because the order is 100, you have to complete 100. These 5 defected will not consider. Then you have to do another 5. Then total become what? Not 100 anymore. Total is 105. Total is 105. Then material as a raw material being used in machining increased. Not only material for 100, but material for more than 100. Then scrap rate must be considered. So CM becomes CM divided by 1Q. So Q, scrap rate, is considered here. However, availability not affecting material. Machine available or not available, material or raw material will not be affected, right? So material CM affected only with the scrap rate. CT also affected with the scrap rate. Because when you have scrap, you have to machining more materials and tool will be used to machine more materials and more tool will be used. Then you need to consider scrap rate in tool. So CT you divide by 1 minus Q, and CT will not affected by availability as well. Why? Because the tool being used is only when tool engaged in the workpiece. It doesn't matter machine available or not. We are not considering, not affecting the tool, right? CL and CEQ actually will not affect it also. CL is a labor salary. يعني الراجل ده بياخد مثلا $10 في الساعة، مرتبه مش هيتغير. يعني $10 في الساعة ماشين افيلابل مش افيلابل، هو مرتبه $10 في الساعة. السي اي كيو برضه الكوست ريت مش هتتغير. مثلا هي بتتكلم $5 في الدقيقة، $5 كل دقيقة مثلا، أو $2 كل دقيقة. لو استخدمت الماشين دقيقتين ب $2 في الدقيقة. مش هتتغير، الماشين متاحة مش متاحة مش هتتغير. طب إيه اللي هيتغير؟ الغير عندي الوقت. التي بي هيتغير. التي بي هيتغير. التي بي اكتوالي هيتأثر بالسكراب ريت اند الافيلابيلتي. الوقت هيتغير، الوقت هيزيد. لما يكون عندك سكراب ريت الوقت البرودكشن تايم عندك هيزيد. ليه؟ لانك هتضطر تصنع more product. Then time will increase. Then time must be affected with scrap rate. Time must be also availability. لان انت لو عندك availability يبقى المفروض تشتغل 40 ساعة، ما اشتغلتش 40، ال 40 بقوا 37، يبقى لازم تشتغل more time عشان المكنة مش available. انت عندك 3 ساعات مينتنس، ال3 ساعات مينتنس دي المكنة وقفت، يبقى you have to work another 3 hours to complete or to compensate the time. Then time here will be affected. Then actually salary and the equipment rate will not affected, but time affected. Then time here considered for scrap rate and availability as well. Then the modified equation will be, as you can see here, CBC equal to CM 1 minus Q, CL CEQ multiplied by TB divided by 1 minus Q. Just give me a second. Okay. And CT divided by 1 minus Q. Q also will affect it. Number of the batch. Batch you would like manufacturing 100. You would like to manufacturing 100, but 100 will become not 100 because 100 affected by the scrap rate. عندك عملت 100 لقيت 5 بايظين. طب هتعمل ايه؟ لازم تعمل 5 تاني. يبقى التوتال الحقيقه مش 100 بقى 105. How many will not consider this one? But you already machined. Who will pay for this one? Who will pay? You must consider this one for cost. It must be considered. Right. RB يعني اديني دقيقه خلاص انا خلصت. RB production rate برضه will be affected because equal to 60 divided by TB, and TB affected by A and 1 minus Q. Then 60 divided by TB, A minus 1 minus Q, because TB affected by scrap rate and availability. This is a modification in the equation. Any question? Any question, guys? واضح؟ Okay. Yes. If you have any question, yes, welcome.
انت سويته مرة واحدة ولا مرتين؟
نعم، قول تاني.
الاتندنس انا سويته قبل يمكن ربع ساعة لما سويته اول مرة، اسويه مرة ثانية ولا شنو؟
طيب خلاص done. You have to make it twice actually. يعني الغياب انا بعمله مرتين. You have to make it twice.
انا سويته
بس
مرة
خلاص.
ما سويته مرة ثانية. قلت انا سويته مرة ثانية.
اوكي. طيب يا شباب، يعني ده كده this is the end of the class today. If you have a question you're welcome. If you have not, if you don't have any question, then this is the end of the class. Any question? I'm listening.
يعطيك العافية دكتور.
شاكرين يا شباب، نشوفكم